Good morning, everyone. Today, I'm excited to share with you fascinating research that explores using Raman spectroscopy for forensic purposes. Now, imagine a crime scene. With evidence everywhere, investigators are going to want to know when the crime happened. By using Raman spectroscopy, we can help determine when a bloodstain was deposited at a crime scene. So you can think of Raman spectroscopy like a fingerprinting technique, but for molecules. When laser light interacts with the sample, some of the light will scatter and change depending on the chemical bonds present within the bloodstain. By analyzing these changes, scientists can identify the unique fingerprint or Raman spectra of the bloodstain without having to physically alter the evidence. Now, why is this important? Well, knowing how old a bloodstain is can help investigators select the most relevant evidence and make their jobs more efficient. We additionally wanted to tackle an additional challenge, figuring out how heated conditions affect bloodstain aging, because unfortunately, not all crime scenes are committed under laboratory conditions. So you can think of the Raman spectra like a fingerprint left on a surface. It changes over time, but when you add heat, it will change even faster. So we built a statistical model that accounts for these changes and is able to predict the time since deposition of a blood stain. To test this, we aged blood at 130 degrees Fahrenheit, which is about the internal temperature a car can reach in summer, for over 1 week. And when we analyzed the results in the model, surprise, it worked pretty well. We were able to accurately predict the age of heated blood, which means we can estimate when a person was at a crime scene, even if a blood stain was left in different environmental conditions. However, there's still much more work to be done. We want to add additional donors and trials to show the reproducibility of our results. Also, we want to account for other variables by broadening the scope of the work to include donors of different ages, races, and sex to ensure that our accuracy of prediction is wonderful. And most importantly, we want to age bloodstains under many different environmental conditions to create a single model that is able to accurately predict the age of a bloodstain no matter what temperature the blood was left in, which I think is pretty exciting. So while this is one small step, this research is like a tool that can be used by investigators to help solve mysteries. It's a small step, but with more research, it can become a giant leap for forensic science. Thank you so much.